Now, does anybody have a clue what we're going to do? Over liters. So, you know that there's 1,000 milligrams in 1 gram. This is the only other number that has grams in it. So, if I multiply that by 100.04 grams for every 1 mole, my grams are canceled. But now I've got moles. I want to get rid of the moles, but I have moles up there. Moles per liter. So if it's 7.1 times 10 to the negative 5 moles over 1 liter, now my moles are gone, and I'm left with milligrams over liters. Some of you are still uncomfortable doing the math this way, and that's okay. So, 7.1 times 10 to the negative 5 moles times 100.04 grams per 1 mole will give you the mass. Right? This is moles times molar mass. So now you know grams, convert it to milligrams, you've got 1 liter. So if I take my mass, take my mass in grams and basically divide it by 1,000, multiply it by 1,000. Now you've got milligrams. And this is all contained in 1 liter, so now your concentration is in milligrams per liter. So either way you do it, you'll get an answer. So what'd you get?
7.10284.
7.1.
10284, and then when you round it's 7.1.
Okay, 7.1 milligrams per liter. What is that in ppm? 7.1. So this ppm is basically, you've got this number up here, and it just ends up being 7.1 ppm. It's just a different way to express a concentration. Okay? Does that help? You're welcome. So you just did B. So, would this be hard or soft water? What? This is question C, 3C. We did B, ppm. It says ignoring the other ions that could be present, how hard is the water? Yeah, use the chart on the opposite page. Table 1.
Less than 50 is soft.
Less than 50 is soft. Wow. Be good to know that. If you had like a test on this or something. And everybody except for Michael would get the table. He has to memorize it. You would. The only thing I'm ever going to ask you to memorize is the formula and names for the 6 strong acids and which substances are nonpolar. That's it. Everything else, if there's information you need to use from a table, you will be provided with that information. I don't believe in memorizing stuff. That can wait for biology. Which substances in the universe are nonpolar? We've done this now twice. Shall I be like a VCR tape? Rewind. Carbon bonded to one other type of element and an even number of that element, or a diatomic element, are nonpolar. One other element, like CO2, CH4, C4H10, those are nonpolar. N2, Cl2, nonpolar. H2O, CH3Cl, polar. Okay, H2S, polar. It's not classified under those first two categories, therefore it's polar. That's it. Okay. Any other question from the homework? So you're awesome at doing net ionic equations then. This is going to be crucial. You have to know how to do net ionic equations. Have to. So if I put an equation up on the board, could you do the net ionic?
Yeah.
Challenge accepted.
Do we give bonus marks?
Do we get bonus marks? The bonus will be you'll be able to do well on your final exam.
Yay!
Hey, because you're going to see questions like this. Okay, I want you to write the net ionic equation, please. Your net ionic equation will always contain your solid and the ions that make it. So there's your net ionic equation. The spectator ions are the other two ions, so K plus and NO3 1 minus. So basically, if you have a beaker, you've just mixed these two solutions together. You have a pile of solid PbI2, and it's quite pretty. It's yellow. And in solution, you have K plus ions floating around and nitrate ions floating around. You don't actually form KNO3. They're soluble, which means they're not making KNO3. Okay? Does that help? All right. So, we're dissolving them in water. Okay? They do not react with water, they just dissolve in water.
Do you have to show them separating to ions?
You might need to know that. So, whatever you do, do not have on the right side elemental chlorine with a charge. All of your halogens form a 1 negative ion. So really, in solution, you have sodium ions and you have chloride ions. Down below, you have calcium ions and chloride ions. Make sure you write them as ions.
So you have to do the next step too, right? And not just that you can hit the ion, like how the ions, if you ask us for.
You can, if I just say write the equation for dissolving of this solid, you can do either one of these two. But this is going to be crucial when we start doing calculations. So, this is sodium chloride. This is my chloride, this is my sodium. So if I have two formula units of them, how many sodium ions will I have? 2. And I will have 2 chloride ions. Okay? But this might not work. If I have this, okay, what is this going to represent then?
That's 2 calcium with 4 chlorine.
I've got 2 calcium chlorides. The pen would represent the calcium. The 2 lids would represent the chlorides. So if I dissolve these 2 in water, how many lids do I have? 4. And how many pens? So if I dissolve 2 units of calcium chloride, I get 2 units of calcium, 4 units of chloride. This is going to be really important when we start to figure out the concentration of our ions. Okay? Hi.
It's all good.
It is. That's good to know. Am I taking a Tyler Howard or a Howard Tyler?
Tyler.
Oh, that's why. I just got an email. Who's Tyler Howard? So it's the other way. It's a Howard Tyler.
No, it's Tyler.
Who is?
First name is Tyler.
Is that his name?
Yeah.
Who is Tyler Howard?
This is my first name.
He's a kid. Yeah. He's the little guy. He doesn't say much. Yeah. Okay.
So those that are project-based learning, we are free.
Excuse the interruption. Could I please have all cast and crew for the fashion show please report to the cafeteria? Go straight there, please, as quickly as you can. Thank you.
Well, how could we? And then I'm looking at it afterwards. Well, you didn't say no. Made it clear. Yeah. So is that the intention? I was waiting for one of you two to figure it out. That was just a joke. But it took you guys about a month to see it.
There you go. So that's what happened. For 1 year. After that,
All right, she's gonna sink her ship. Okay. Yes, I think it already is, okay? All right. So, if I have oh shoot, 0.1 mole per liter. Whoops. If I have 0.1 mole per liter sodium chloride, what's my concentration of chloride ions? Should I move this up?
6.23 times 10.
What is my concentration of chloride ions if I have 0.1 mole per liter sodium chloride?
6.23 times 10 to the 22 chlorine.
Yes, I just did.
But before.
Sodium chloride. If I have 0.1 mole per liter of this, how much of this do I have? 0.1 mole per liter. Let me show you how to demonstrate that using math. There you go. You just proved it. No, because if I have one pen, I have one lid and one pen. Chloride. Sodium chloride. I don't have half the lid, right? I have a whole lid. When they come together, they're two parts, right? Making one part. So when I split them up, I have one of each, not a half of each. Don't think of it as half of the whole. See that? If I have 10 of these, how many of these will I have? 10. If I have 100 of these, how many of these will I have? If I have Avogadro's number of these, how many of these will I have?
6.23 times 10 to the
Yeah. So if I have 0.1 mole per liter of the entire thing, I will have 0.1 mole per liter sodium. 0.1 mole per liter chloride.
Oh, so you'd have the same.
Right. Now, okay, this is awesome. Okay. Okay. If I have 0.1 mole per liter calcium chloride, How much calcium ions will I have? Now, how much chloride ions will I have?
0.2.
Yes.
No, it was 0.2 chlorine. We have 1/5 of chlorine atom. Weighs a lot.
All right? You're like, no. It's, I know. So you got to think about it like this, right? Just think, pens, lids. Okay. What's going on? If I have 50 milliliters of 0.1 mole per liter sodium chloride, and I add 50 milliliters of water, what will be my concentration of chloride ions? Square brackets mean concentration. What is the concentration of chloride ions?
0.05 moles.
You have to do this first, right? So I had 0.1 times 0.05. So my second concentration is actually 0.05 moles per liter. So my chloride ions will be 0.05 mole per liter sodium chloride times 1 chloride for every 1 NaCl. 0.05. Okay? So, first beaker, calcium chloride.
Because it's 50
Right? Well, yeah. Okay, so there you go. Find the moles in each original beaker. Add the moles together, divide by the final volume to get the final concentration. But don't forget to check how many ions are in each formula initially.